When you gaze at the night sky, you're seeing ancient light, sometimes thousands of years old. But to see the universe's first stars and galaxies, you need a special kind of eye, the James Webb Space Telescope, or JWST. Floating a million miles from Earth, Webb is humanity's most powerful time machine. Its mission, to look back in time and reveal the universe's origins. Unlike Hubble, which sees mostly visible light, Webb is an infrared detective. It captures light invisible to us, the kind that heat gives off. Why infrared? Because as the universe expands, light from distant objects stretches into the infrared spectrum. Webb is built to catch these ancient, stretched-out signals. Imagine a police siren dropping in pitch as it speeds away. That's what happens to light from distant galaxies, a phenomenon called redshift. The first galaxies are so far and moving so fast, their light is now infrared. Webb's giant golden mirror is designed to catch these faint whispers from the dawn of time. This lets us peer through cosmic dust, see the atmospheres of distant planets, and study mysterious visitors from beyond our solar system. The James Webb Space Telescope isn't just another telescope, it's a new chapter in our cosmic story. With Webb, we're not just looking at stars, we're uncovering the universe's deepest secrets. The adventure has only just begun. Our solar system is a familiar neighborhood, but sometimes we get a visitor from far beyond. These rare guests are called interstellar objects, cosmic wanderers from other star systems. 3I Atlas is one of them, only the third ever detected. The I stands for interstellar, confirming it came from outside our sun's reach. Atlas, an automated sky survey, first spotted it as a faint, fast-moving object. At first, astronomers thought it was a typical comet, but its trajectory was all wrong. It was moving too fast, on a path that proved it was just passing through. This makes 3I Atlas a scientific treasure, a physical piece of another solar system. Studying it is like getting a rock sample from another world without leaving home. By analyzing its composition, we learn about the building blocks of planets around other stars. These objects are small, dark, and fast. By the time we spot them, they're almost gone. That's why Webb's sensitivity and deep space vantage point were crucial. Webb could catch up with 3I Atlas and study it in detail before it vanished forever. It was a race against time and a golden opportunity for discovery. Each interstellar visitor is a priceless clue to the galaxy's secrets. How do you study a faint, fast-moving object in deep space? You use the most powerful infrared telescope ever built. Webb's observation of 3I Atlas was a carefully planned investigation, not just a snapshot. The telescope had to track the object precisely as both it and Earth moved through space. Astronomers used two key instruments, NIRCam for sharp images and MIRI for detecting heat. NIRCam reveals shape, size, and surface reflectivity. MIRI measures the object's thermal glow. By combining these, scientists can determine if the object is big and dark or small and shiny. MIRI is so sensitive, it could spot the heat of a bumblebee on the moon. This dual approach let Webb build a detailed profile of 3I Atlas. For the first time, we could truly see an interstellar visitor in action. When Webb's data arrived, scientists were stunned. Earlier estimates suggested 3I Atlas was just a few kilometers across, but Webb's infrared eyes revealed it was much larger, about 34 kilometers wide. That's over 3 times the height of Mount Everest, rivaling the size of some of our solar system's moons. This discovery changed everything. 3I Atlas isn't just a small rock, but a massive planetary building block. Its size suggests a complex history and a rich birthplace in its home system. The surprise came from its darkness. NIRCam showed it reflects very little sunlight, like a lump of charcoal. Other telescopes saw a faint object and assumed it was small, but Webb's heat measurements told the real story. 3I Atlas is huge, dark, and far more substantial than anyone imagined. This interstellar traveler is a heavyweight among cosmic visitors. Webb's unique abilities revealed a hidden giant passing through our solar system. Sometimes the universe's biggest surprises are the hardest to see. Webb didn't just measure the size of 3I Atlas, it revealed what it's made of. Using spectroscopy, astronomers scanned for chemical fingerprints in its infrared light. The results? A surface rich in complex organic molecules, silicates, and carbonaceous materials. Think of it as a mix of fine sand and soot, giving it a dark, non-reflective crust. This crust may have formed as cosmic rays bombarded it during its long interstellar journey. The surface isn't uniform. Some patches are richer in silicates, others in carbon. This patchiness hints at a turbulent past, perhaps from collisions or impacts. 3I Atlas is a hybrid, the size of a major comet, but a surface like a primitive asteroid. Its composition suggests the building blocks of rocky planets are universal. A visitor from another star, made of the same stuff as Earth, proof that cosmic chemistry is everywhere. Webb's findings connect us to worlds far beyond our own. Normally, a comet near the sun grows a glowing coma as its ices vaporize. Given its size, everyone expected 3I Atlas to do the same. But Webb found almost nothing. No significant coma, no dramatic outgassing. This was a puzzle, a giant icy body behaving like a dormant asteroid. One theory is that 3I Atlas has a thick protective crust formed by cosmic rays over millions of years. This crust could insulate its ices, preventing them from vaporizing near the sun. Or perhaps its ices are less volatile, or have already been lost during its long journey. Whatever the reason, its silence is a crucial clue. 3I Atlas may have been processed differently than our comets or formed in a unique environment. Its quiet passage tells us as much as any outburst could. Sometimes, what an object doesn't do is just as revealing as what it does. The mystery of the missing coma deepens our understanding of interstellar visitors. The story of 3I Atlas reshapes our understanding of planetary systems. For decades, we only had our solar system to study. Now, interstellar objects give us new data points. The sheer size of 3I Atlas suggests planet formation is robust and sometimes chaotic. Its composition, dark, carbon-rich, with silicates, shows the ingredients for rocky planets are common across the galaxy. Each interstellar visitor strengthens the idea that Earth-like worlds could be everywhere. Studying 3I Atlas helps us understand our own origins. Every interstellar object is a message from another world, and Webb lets us read it. The universe is more connected and more familiar than we ever imagined. The encounter with 3I Atlas is just the beginning. With Webb and new sky surveys, we're ready for the next interstellar visitor. Soon, we may find many more, each with its own story. By building a catalog, we'll learn how diverse these objects are. Future observations could reveal even more about their chemistry, maybe even the building blocks of life. Some scientists dream of intercept missions to study or sample these objects up close. Webb's data on 3I Atlas is laying the groundwork for these future adventures. We're on the verge of touching pieces of other worlds. The search for cosmic visitors is only accelerating. The story of 3I Atlas, revealed by Webb, reminds us of our connection to the cosmos. Interstellar objects are tangible links between our solar system and the galaxy beyond. They show that our solar system is part of a vast, dynamic ecosystem. The same chemistry that built Earth is at work around other stars. The journey of 3I Atlas spans millions of years and unimaginable distances. By chance, it crossed paths with us, and we were ready to see it. Every Webb image, every data point brings us closer to answering. Where do we come from? What is our place in the universe? 3I Atlas is a thrilling new clue in that quest. Our story is woven into the fabric of the galaxy. We are not alone, and that's the greatest discovery of all.